Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and today we will be looking at the modulus function in detail. So let's get started. Okay, now let's start with modulus function. Modulus function, also known as the absolute value function. Let us define a function f from the set of R to R such that y is equal to mod x, which is also equal to the square root function, that is square root of x square, for all real values of x. Now, what do we mean by mod x? Mod x, or the absolute value function, gives us the distance of a real number from 0 on the number line. So it gives us a distance from 0 of a number. Since it is a distance, it is always positive. And let us take an example. Suppose I want to find mod of minus 5. Then on the number line, minus 5 is here, this is 0. Mod of minus 5 will be the distance between minus 5 and 0, which is equal to 5 units. The same goes if we want to find mod of 5. Mod of 5 is also 5 units from 0. So it is giving us the distance of the number from 0. With this, we can define it into piecewise function. For all values of x greater than or equal to 0, that means x is positive or 0, in that case mod x will come out of mod as it is and we will write it as x, since it is positive already, or 0. For x less than 0, that is when it is negative, mod x will be written as minus x, since the negative of a negative number will give us the positive value, which is the absolute value of x. So this is how we define the modulus function. Now why have I written that mod x is equal to the square root function? This is an important why. So let's understand. To understand this, we need to know that the square root sign, this always means only the positive value. Okay, it does not mean negative value, it only means the positive value. So suppose if I take root of 16, this can be written as either root of 4 square, or it can also be written as root of minus 4 square. Now 4 is positive, so this can be directly written as 4 by removing the square and the square root sign. But since the square root sign means only positive, when minus it is written in this form, after removing square root, I will write it as minus of minus 4 to get a positive value, which is ultimately equal to 4, which gives us the absolute value. That's why both of these functions are equal. If I look at the graph of the modulus function, now y is equal to x when x is greater than or equal to 0. That means for positive or for non-negative values of x, y is equal to x. So if I make the line of y is equal to x, it will be equal to, we will take only that part of the line which is for positive values of x or 0. We will not include this part of the line. When x is negative, y is equal to minus x. So if I make the line y is equal to minus x, I will not include this part. I will only include the part for when x is negative. So this solid line gives us the graph of mod x. This is the graph of mod x. If we talk about the domain and the range, the domain is the set of real numbers as the function is defined for all real numbers, and the range of this function is greater than or equal to 0. Y is greater than or equal to 0. Since y is always non-negative, that is y belongs to the closed interval, the set of closed interval 0 to infinity. This is the range of modulus function. Let's look at some properties of the modulus function. Properties. First one, mod of x is always greater than or equal to 0. As we just saw, it is always greater than or equal to 0. Mod of x into y is equal to mod x into mod y. This can be proved by writing mod xy is equal to square root of xy square, which is equal to square root of x square into y square. We can write the square root sign on each of them individually, and this would mean this is equal to mod x into mod y. This is the proof. Third, mod of x upon y is equal to mod x upon mod y. Again, this can be proved in the similar fashion. This is the third property. Fourth, mod of minus x is equal to mod x. Since the mod of a negative number will be equal to the mod of the positive number, it is equal. Fifth one, mod of x minus y is equal to mod of y minus x. It won't matter if we take a negative of this common, of negative inside common, and since because of this property the negative will be removed and it can be written as mod of y minus x. So this is true for all values of x and y. This symbol stands for all. So start using mathematical symbols as well. Very important. Sixth property, mod of x whole square is equal to x square. Since, proof of this, mod of x whole square can be written as root of x square whole square, which is equal to x square. Seventh property, if mod x is equal to a where a is positive, then x is equal to plus minus a. It can either be equal to a or minus a. For example, say mod x is equal to 2. This would mean that x is either equal to 2 or it can be minus 2 as well. Eighth, if mod x is equal to mod b, then x is equal to plus minus b. This is also true. For example, say mod x is equal to mod of minus 5. Mod of minus 5 is equal to 5, and from here mod x is equal to 5. This means that x is equal to plus minus 5. So we looked at the modulus function. These are all the properties and inequalities. Okay, now let's look at an example to use those properties. Solve for x, mod of x plus 1 is equal to mod of 2x minus 3. Using the property that mod x, if mod x is equal to mod b, it means that x is equal to plus minus b. Here we can write that x plus 1 is equal to plus minus 2x minus 3. So let's take them separately. X plus 1 is equal to 2x minus 3 and x plus 1 is equal to 3 minus 2x. This means x is equal to 4. From here 3x is equal to 2. This means that x is equal to 2 by 3. Therefore x is either equal to 2 by 3 or equal to 4. Okay, so we looked at the modulus function in detail in this video. I hope you liked the video. If you did, hit the like button and subscribe to our channel and keep following for more videos like this. Thank you.